Hello, everyone. Thank you so much for joining us this afternoon. I hope you guys didn't have to wait too long in the hot sun, although secretly I was hoping that there'd be a long line for our talk. My name is Ray. I'm a product manager on the Android media team, and I'm responsible for Android Pro Audio. Android Pro Audio is an initiative that we launched last year to bring together device makers, silicon partners, and Android engineers to provide a true, professional, performant audio platform for Android app developers. This means being able to write apps that use MIDI, high-resolution input and output, USB digital audio, floating point audio processing, and all of that with a round-trip latency of less than 20 milliseconds. Now, when we announced this initiative, we knew it was going to be a multi-year effort with a lot of moving parts, some out of our control. But even though it's been only a year, we've actually seen some really exciting developments from our hardware and software partners. And so with that, I'd like to introduce you to Dan to show some really cool audio apps.
All right. So thank you very much. I'm Dan Galpin. I'm a developer advocate, and I work with a lot of partners to help build great audio experiences on Android. And I wanted to first do a call out to my colleague, Don Turner. He couldn't be here today, so this is Don Turntable Turner as a young guy working on his pro audio stuff. And then, of course, this is what his desk actually looks like today. It's a little neater. But there is a lot of passion in this team about pro audio. And I just want to make it clear, every single one of us up here is a musician. Every single one of us up here cares passionately about what we do. All right. It's not that mind-blowing, but it's still pretty darn cool. So let me get started with the first demo. This is on a Nexus 9, and we're running DRC. And a lot of people have seen apps like this. OK, if we can have the audio output, tell me that's working. All right. OK, that's pretty cool. We got some nice low bass here. But what's really neat about this is in addition to this low bass, I've also got this keyboard plugged in here. And what I can do is I can do these high patches at the same time. And this is taking advantage of a feature we added in Android M to do proper MIDI. And what's really cool about this is in addition to actually being able to do MIDI output like this is doing it, you'll also see MIDI input. And this device can actually reconfigure itself to act as a MIDI audio interface. You can plug this into a PC, and it actually looks just like a MIDI device. And this is cool because DRC actually can work as a MIDI synthesizer for your desktop workstation, which is awesome. And we actually have an example of this over in the Pro Audio Sandbox for all of you guys that are here. All right, so the next demo, I'm going to pull this out. The next demo I'm going to show off is something very, very cool. And this is the one I really wish Don could have been here for, because Don is like an amazing, amazing DJ. I, on the other hand, am like super rank amateur. But we're going to show the DJing app, and we're going to show this really awesome device, which has powered itself off. Let me switch this off again. Hold on. Give me like a moment here. This is what's great. You know you're getting live demos when I'm like, come on, work. Yes. All right. So now I've got to do this all from scratch. This is all set up for you guys beforehand, so there'd be none of this kind of stuff going on. But that's what's great about doing this stuff live. So we can hear the audio from that. And this is really cool. It's showing off really, really cool low latency Bluetooth along with low latency audio. And so I can go and mix between these two tracks. And that's what DJs do. They create rhythmic patterns by going between two different tracks like this. And you see how responsive this app is. Of course, I can also do this stuff like scratch against the record as well. So that is an example of doing really cool pro audio work, DJ style here on Android. I'm going to unplug this. I'm going to show one more app on this device, though, so we can keep this going. And this app really needs no introduction. All I have to say is, thanks to our partners here at Korg for doing K-Oscillator here on Android. Really, really awesome. Again, super thank you to them for the support of Android Pro Audio. OK, I've got one last demo to show you guys here. And last, but certainly not least, here we are. OK. Should be all plugged in and connected. All right. So this is the noise synthesizer from Roly. And this is cool. You're seeing a virtual Seaboard Rise, which is an amazing instrument. If you're here at I/O, you can actually check one out in our Pro Audio Sandbox and get to play on it yourself with this amazing multi-touch panel. What's really cool is that it's not just a keyboard, but I can actually move up and down to get different effects. I can also slide across here to do pitch bending, and of course, fully multi-touch, fully multi-channel. And it's really, really powerful what you can do with this. You can create almost any instrument with incredible amounts of expression. And this is all running on the Juice platform, which has been updated so that anyone can build amazing pro audio apps with really, really low latency audio. So a big shout out to our partners and friends over at Roly for putting this together for us. And again, there's some amazing, amazing people. You go onto YouTube, just watch what people do with the Seaboard, watch what people do with noise. It's absolutely, absolutely incredible. So that's the kind of stuff we're doing. Really low latency audio, really professional applications. All right, we can go back to the slides now. All right, so.
Yeah, so I know I've seen this in rehearsal, but that was super impressive every time I see it. Thank you so much. And again, thank you to our partners. Roly, eDJing, DRC by Imaginando. Thank you so much.
So thanks, Ray. I hope you agree. These are some awesome experiences. Now, developing apps like this isn't easy, and our partners have run into many problems along the way. So I'd like to share with you some of the most common problems they encounter and the solutions, so you don't have to go through the same level of pain when you're developing your audio apps. Now, to put this more interesting, you saw a preview of this. I'm going to put some code on screen, and I want you to see if you can figure out what the problem is with this code. Okay, does anyone? Comment on hands. What's the problem with this code? Anyone? Okay, yes.
So it has a fixed sample rate.
It has a fixed sample rate. Yes. Okay, that is excellent. Thank you. You can tell we've got people doing pro audio out here. It's fixed, and that's a problem because every Android device has a preferred rate that is set by the system, and it's usually not 44.1 kilohertz. So not only is this a fixed sample rate, but it's usually going to be the wrong one. And if that happens, your audio is going to be on a resampler. And so it's not going to be able to go through the fast path, which means you're not going to get the lowest latency. So how do we solve this? We can use the Audio Manager API and query for the device audio property and pass that over to OpenSLES. And I know what you're saying to me, like, wait, I'm having to use JNI. Like, what? Look, this is a very small amount of JNI. It's very, very little effort. And honestly, this is an enormous performance gain. It's really pretty simple. So once again, this is how you get the native sample rate for the device. Okay, another problem is I'm getting high audio latency on every single device. Why would this happen? All right, so tell me, what's wrong with this code? This one's actually pretty straightforward. Anyone? Why do I always see the same hands?
There's
okay.
another one back there.
No, there is. Okay, so shout it out.
It has too much buffer.
It's got too big of a buffer. It's got too much buffers. Yes. We should have parting gifts for this. This is awesome. Okay. So yes, that's exactly the problem. Not only that, it's a fixed size. So it's way too large for low latency output. At 4,000 frames, we're talking 83 milliseconds. Now, back in the old days of Android, back when I first started ages ago, that actually wasn't that big of a buffer. But today, our devices are way faster than that. So we're talking about 83 milliseconds of just in this buffer. So you're not going to get super low latency audio that way. So what's the solution? Of course, what we want to do is go back and ask Audio Manager, say, what is the best buffer size we should be using? What's the optimal one? And the device will tell us. And then if you use that buffer size in your OpenSLES callbacks like this, you're going to get the fast mixer, you're going to get the best audio playback in your apps. Okay, well, this doesn't solve all of your problems, because what happens if you actually are doing this cool synthesizer that you wrote, and you're hearing glitches, but you notice, wait, I tap the screen and my glitches go away. Okay, so what you're seeing here is Android trying to do stuff about battery life. Okay, and what happens is if you're not touching the screen, Android goes, well, you're not doing anything important. No one's interacting with me. And so it scales back the CPU. And this results in late callbacks because you aren't able to do as many work cycles. This is actually something we call the interactive scheduler at work, actually trying to help you save battery, except you really don't want that because you really want cool audio playback. So there is actually a way to sort of work around this. And it's kind of a hack, trick, horrible thing that we'll have a better solution for very soon. Creative workaround, I like that, yeah. So this is what happens. So the system decides to throttle the CPU based upon how often the user is touching the screen. So what we can do is we send fake touches and convince it that the screen is still being touched. I know, hear the groans from the audience. Hey, look, don't shoot the messenger, okay? I mean, but no, so now Android will go, okay, the screen is constantly being touched. It thinks that it's in interactive mode. And this is really important if you're doing something like input, or if you're using, even if you're doing like a VR app and you're using sensors, like you're not touching the screen, Android might say, whoa, I shouldn't be doing anything now. But so this does actually work. It convinces Android the screen is being touched. And seriously, like, yeah, we're going to do something better. Okay, last problem is the one I hear the most. We spend a lot of time debugging. We get audio glitches and crackles. They've done all the other things right. And for example, we've got an app that's running on a device with a 192 frame size buffer and a sample rate of 48 kilohertz, which means you're going to get callbacks every 4 milliseconds. And in those 4 milliseconds, you have to generate 192 frames of audio data. And if you don't, you're going to get a glitch. But the problem is that in fact the cause of it is that you're not always able to supply it in time. And the real question is why? Why was your app not always able to actually supply this data in time? And there are two possible causes. One of them is that you might be blocking, or you might be doing too much work in the callback. And let's take a quick look at some causes of those. So first thing you want to do is check for any blocks in the audio callback. This means going through your code and just analyzing it, examining it and checking for things like waiting on other threads, JNI calls, which basically is kind of like waiting on other threads because it adds synchronization, which could block you. Memory allocations, believe it or not, memory allocations actually can block you. Not shocking. System calls also can block, and of course, you can use systrace with audio, sched, and freq. And how many people here use systrace? Raise hands. That is not nearly enough. More people should use systrace. It is an awesome, awesome tool. If you want to learn more about using systrace, you can come to my session or come online for tomorrow at 9 a.m. over in Ursa Minor. Okay, and I'll be talking about systrace. Once you've eliminated any blocks, you need to figure out how much work you're doing. And you can do this using clock get time, as this gives you nanosecond accuracy. And logging inside the callback is problematic, so you want to keep that to a minimum. And a trick you can use is to keep a count of the callbacks and only log one every X number of calls. And there's even better tricks like keeping a ring buffer, or you can use the trace command with systrace, which is pretty cool, to create trace segments. There's a native API we added an M for that, so it doesn't even force a JNI call, which is great. And then the other thing that can drastically affect your performance is your build configuration. Always make sure that you do not debug your debug build. I know this doesn't make sense, but when you're doing performance debugging, you always want to make sure you're actually looking at your release build, because it's going to be a lot faster. We take out a lot of things. Also make sure to check your compiler flags. Hardware float and neon can make a massive, massive difference. Please check out our high-performance audio website, where we publish the flags that we actually use as a team. So make sure the compiler is actually generating what you think it is. Use like WA and ASLH to dump annotated assembly if you're not sure. And this is really great. If you've ever wanted to learn what compilers do and just how great they can be, and sometimes how not great, take a look at the assembly that's generated. It's very, very eye-opening. Okay, and this is kind of the hardest and most painful one for me. Don't use more than 20% of your callback budget to generate data. And so what this means is that if you're taking more than about a quarter of that time, what you should do is try to scale back things, scale back effects, scale back the amount of polyphony, because the chances are you're going to get a glitch. Or even worse, get a whole bunch of glitches, or maybe the device will even heat up. So by trying to take only about 20 to 25% of that time, you really, really radically reduce the chances of glitching. And ultimately, we want to make this better. And we're working to increase this both with bug fixes in N, which Glenn will talk about, and by working closely with our silicon partners. But for now, especially on older devices, and we're talking about current Android, sticking to this rule will give you the best stability on a wide range of devices. So that's about all the war stories I have time for today. But you can read more about all of this and keep up with any new developments on the Android Pro Audio webpage. All right.
So as you can see, it really is possible to write a great professional audio app on Android. Dan, thank you for all the tips, the pitfalls to avoid, and the best practices. Thank you for that.
All right.
And of course, it should not be that difficult to make a great Android audio app. So we're not going to be happy until we have an easy-to-use API and an audio platform that can guarantee consistent, predictable performance. And that's also something that's not just available on a few devices, but on a myriad of devices. So we're a little ways off from finishing our Android Pro Audio story, but we've done some really important work this year. And to give you a progress report, I want to introduce you to Glenn Latency Crusher Caston.
I like that name, Latency Pressure. It's much better than my other nickname, which is Glitch Caston. It was really painful for me to see Dan talking about glitches because I spend a lot of my time thinking about glitches and listening to them. Anyway, so for me, I really believe that creativity should be for everyone, that everyone should feel empowered to be creative. And we all deserve it. It shouldn't just be for a select few. And I believe that there's billions of people out there, including Android users, who should be able to be creative. In my family, we're musicians. 4 of us play piano, including me. And I'd like to introduce to you my son, rap master Aiden. He likes to create music too. He plays acoustic piano and also electronic keyboards and microphone. Unfortunately, he doesn't play music on Android, not yet. And this gives me such a pain, even more than hearing glitches. And the reason is because Android just hasn't had the consistent level of high performance that creative audio applications need. And Aiden's not satisfied, and other musicians haven't been ready yet, or haven't been satisfied yet either. Creative audio applications require a lot of CPU. They require it consistently. They need to run every few milliseconds. This is pro level of performance. And that's why we call it pro audio. The pro is for the pro level of performance, not for who happens to be using it. We believe that pro audio, again, is for everyone. That's where Android comes in. That's our strength. One of our strengths is being able to be accessible to many, many people, the openness, the wide range of form factors and price points. My work mission is to reduce audio latency latency, to improve performance, to reduce glitches, things like that. We introduced the Pro Audio program overall a year ago, but actually I've been working with my colleagues for over 3 years now, initially on latency. In 2013 at I/O, we announced some major reductions in output latency, along with my colleagues. And then the next year, we announced reductions in input latency. The following years, we talked about USB audio, which enables really high quality audio interfaces. And we also introduced MIDI, which is what makes music tick. That's my slogan. One thing we found, though, was that features were not enough, that we had to have this consistent level of performance, and both our app developers and our users needed a way that they could tell really easily whether a device was going to be capable of that level of performance and have all the features they needed. So we introduced last year this thing that we call the Pro Audio Feature Flag. It brings together all the key things that you need for pro level of performance. Low latency, MIDI, USB, the 24-bit data path, and I'm probably missing something else, but it has basically all the core elements. It gives us something to shoot for, us personally in the Android framework team, and it also gives our OEM partners and our silicon partners something that they can shoot for. I mentioned that one of Android's strengths is the diversity of our ecosystem. We have a large number of different form factors, different price points, and things like that. And for Android, it's not realistic at this point to expect that we can get Android Pro Audio performance everywhere. And we acknowledge that with the Pro Audio flag. So now we have something to shoot for, something to differentiate. And certainly, yes, I would like to have more and more devices support that. But initially, it's our first step. And at the beginning, we only had a few devices in the Nexus family that claimed the Pro Audio flag, but things are changing. I see hope now for additional devices from other OEMs, from other silicon makers that are also going to be supporting the Pro Audio flag. So please stay tuned for that. So I mentioned earlier that in one of my main day job is getting rid of glitches and decreasing latency. It turns out that we can't do that all just in the framework. Certainly part of it is in the portable framework, but a lot of it has to do with the device-dependent code. So I work really closely with partners. These include partners within the fellow Googlers in the Android framework and kernel teams and performance teams, but also external partners, device OEMs, silicon makers, people such as that. There's one partner that I've been working with in particular that I want to mention now. He's a fellow Googler. He works in the Chrome OS team, and he's really helped us to investigate and challenge some of the assumptions that we've been making about latency. Let me give an example of one assumption that I used to make that was totally incorrect. People would say, oh, your round-trip latency is whatever, 20 milliseconds or whatever. What's the output latency? And I would say, well, I don't know, but let's call it a half, or maybe it's a little more than half. Well, that's not good enough. And I'd like to introduce Mark. He's a physicist by training, and he cares about numbers and getting them right. And even better than that, he works with lasers.
Thanks. Hi, my name is Mark. I work on the Chrome OS Touch team, and we care a lot about latency, and I'm guessing a lot of you do too. Now, it's not only latency. There are a bunch of different ways an application can interact with the physical world, and all of the interaction channels listed here have a typical latency of milliseconds or tens of milliseconds. Now, timing physical events with millisecond accuracy is no rocket science, but when you're trying to time them relative to events that happen inside the CPU, it gets pretty messy. It looks something like this. And then when you try to touch the device and use the touch screen with all those probes sticking out of the guts of the phone, it gets very frustrating. I tried it. That's one of the reasons that the numbers we usually see are round-trip latencies. I'll be using a drumpad application as an example here. The pipeline of the event looks something like this. So the round-trip latency in this case is the time from the moment somebody touches the screen and until sound comes out. But the subsystems involved in such a round-trip represent a bunch of different engineering teams, often spread across different companies. And if there is a bug, who should be looking for it? Blame wars are no fun. And as a physicist, I have a little obsession with good measurement instruments. And for the last several months, I was lucky to work on building one that does exactly the kind of measurements that we are looking for. The basic idea is that we use a device that synchronizes clocks with the phone. And then we can separately measure the time that passes from the moment we touch the screen and until the app got the event. And in the other direction, from the moment that app initiated some output and some visible or audible change has been produced. We called it the Volt Latency Timer. Now, this is a very early prototype in audio setup, but it's fairly simple. This is a more recent device that can measure latency on most of the channels that I've mentioned earlier. The good news is that it can work without the need to modify the device or even root it. And we have recently open sourced this project. It's now all on GitHub. And Volt has produced some interesting results for Android Audio and for Touch as well. Back to Glenn.
One thing here. Thank you, Mark. One thing here that shocked me was seeing that the audio output latency here was 13 and the input was 5. I'd been telling people incorrectly, oh, just guess half and half. Well, I was totally wrong. When you think about it, it makes more sense. It has to do with the number of buffers and where they are in the pipeline and things like that. But it just shows you how important it is to actually measure things and not just guess. So, together, working in the Android framework team, together with our partners in the kernel team, performance team, our silicon partners, our OEM partners, we've made a lot of progress in reducing latency and improving performance. I want to now turn the subject to what we're doing, what we've just been working on just the last few months, so you have a sort of a feeling of what we're up to right now. And I'll talk about what's going on in the in release. First of all, I've made a lot of mistakes in my career, I'm happy to admit that. One of them was I was so aggressive at trying to reduce latency that I took some shortcuts and cut some corners that have, in retrospect, turned out to be not advisable. One of those was on the output side, in the device driver, we've always had double buffering, and there's some very good reasons for that. But on the app level, we're encouraging app developers to do single buffering in the application, with the rationale being that the app could provide the data immediately and everything would be okay. That works fine for apps that create sine waves, but fortunately or unfortunately, those are not real Pro Audio apps. Real Pro Audio apps such as the ones that you saw Dan demo earlier, use a huge amount of CPU, and they would like to use way more than 20%. And to do that and do it reliably without glitching, even under stressful conditions, you need to have double buffering in the application level. So I'm happy to announce that in N we're finally enabling double or even further buffering in the application level for those apps that need it, and with an accompanying very slight increase in latency, of course, but it's usually not important. Then the other thing I want to mention is for those of you who love the SDK is still there, and we've improved the audio latency on the audio track APIs too, so that you can take advantage of some of the improvements we've been making in latency there too. You've heard at both the keynote and lots of sessions this week about our VR effort. And VR is very focused on performance, especially predictable performance. It turns out that VR is by nature a real-time kind of application, very similar to Pro Audio. And their needs are very similar to ours. So we've been working very closely with VR and the performance teams. Right now, the features that you've heard about with VR, such as sustained performance mode, those are only available for VR as of now. However, we are working together, and I really hope to be able to bring those kind of performance guarantees to other vertical domains, such as Pro Audio and any other use cases like that. As long as we're talking about VR, I wanted to mention there's a VR session tomorrow morning at 9 a.m. I hope you can attend. One of my colleagues is presenting on VR audio. And also, we also have another presentation by Dan tomorrow morning, also competing with that on the NDK. So both should be of interest to you, and hopefully you can split yourselves to go to both sessions. Okay. So here again is the website for all things audio, for all things Pro Audio. It's bit.ly/performance-audio. If you don't remember any other URL, please remember that one. So although we have been making progress on over the last 3 years, I do want to acknowledge that we're not done yet. And we certainly have a lot more work left ahead of us, and some of which I know about, some of which I can't predict yet, because we haven't hit them yet. What I will share with you is what we're working on right now that we know about. And I'm acknowledging that, yes, these are problems. And the good thing, though, is despite these problems, it is possible to get real work done on Android, as you've seen these 4 apps earlier. The first thing is more predictable CPU scheduling and CPU bandwidth, so that you don't need tricks like the fake touch, and also so that you can use more than 20% of the CPU. The next is our API. We recognize that OpenSLES is a hard-to-use API. It requires a lot of boilerplate code, and just saying OpenSLES is awkward. I want a simpler name. So we're listening to you developers, and I can't make any promises yet about what it will be and what it will look like, but we are working on a new API. And don't worry, if you love OpenSLES, it will still be there. Finally, round-trip latency latency our goal for the Pro Audio flag is 20 milliseconds, and that is good for many, many applications, especially applications that only do output-only processing, because then they don't, their latency is only a portion of this. However, there are applications such as guitar processing, voice processing, that can benefit from even lower latency. So we are working towards that magic 10 millisecond round-trip latency figure, and I want to achieve that without causing power problems. It turns out in the lab, we have hit 10 millisecond round trip, but it used too much power, and so it's not really ready for release yet. So I won't be done with this effort until Aiden is happy being creative on Android, and until all of you are happy being creative on Android. Thank you for coming today. At this point, I want to switch to some acknowledgments. You already heard some acknowledgments from Dan about our app partners, a few of whom are in the room today, so look for them later on. For me personally, though, the people that I work with most closely are silicon and device OEMs, and I want to acknowledge a few of them by name, although I've worked with many of them. First of all, Qualcomm has really worked hard to reduce the audio latency in their signal path, especially in the DSP. They've been optimizing that recently. Another company I'd like to acknowledge is NVIDIA. They've been focusing on improving performance and reliability and stability of scheduling and task wake-up. I'm really thrilled to announce that the demos that you saw today, at least one of the demos, was done on the NVIDIA Shield K1 and using an early build of Android that supports Android Pro Audio Flag. And for more information, please check out these URLs. NVIDIA will be happy to, if you sign up for there, to let you download over OTA a special developer preview of their Android Pro Audio Access. And if you have questions about that later on, we have people in the audience. We have Prajakta. Thank you, Prajakta. And Bill, who can also answer your questions about Android Pro Audio on NVIDIA. There's one company, though, that I want to acknowledge that I work with even more than, I want to give them a very special thank you, and that's Samsung Mobile. The reason is that we're kind of late to the Pro Audio party. We started thinking about it a few years ago, but it turns out Samsung Mobile has had that on their radar for many, many years. They saw a real gap in Android compared to our competitor platforms, and they started working on it. And over the last few years, they've been working on the Samsung Pro Audio SDK, evolving it, coming out with multiple releases, and along with accompanying apps that work well on the Pro Audio SDK. So I want to acknowledge Samsung Mobile and invite both Taemin Cho and Johnny Seo up to the stage. Thank you. Do you have a mic? Yeah, thank you. Thank you. Okay, thank you. Okay. Yeah, okay.
Hello, my name is Johnny Seo. I'm product owner of Samsung Professional Audio and Sound Camp. I really appreciate Glenn and Ray inviting us on this stage. As you saw in this session, Android Pro Audio has great potential and opportunities for Android developers. And I believe it will be great, even great with Samsung Professional Audio and its collaboration with Android Pro Audio. Our lead engineer, Taemin Cho, will give you more details about it.
Hi. Samsung Professional Audio, also called SAPA for short, is Samsung's own professional audio framework. It was first released in 2013, and it has two major features. Of course, the first one is the low latency audio. The first version showed the 60 millisecond round-trip latency on Galaxy Note 3. And the second one is the inter-application audio routing, which allows the streaming audio and MIDI between different applications. Yes, less more details about the inter-application audio routing. So here is an audio application you made, and you want to add some effects to the sound. Then you have to build every effects into the same application. Or using SAPA, you can connect your app to other effects apps. You can connect as many apps you want, depending on the CPU, in whatever form, in serial and parallel, with no additional delay. SAPA's inter-application audio routing is based on the well-known jack audio connection kit. So if you are familiar with the jack already, then you just say, gotcha. So with this, even you can build a PC-like DAW app, so you can load multiple plug-in instruments and effects, run them simultaneously, and mix the sound. It's highly extensible. And Samsung also provides their own DAW app, which has a plug-in architecture. So you just make a plug-in and use that. SAPA, in order to achieve the low latency, SAPA actually, we made SAPA independent from the audio, Android audio system. So that's why SAPA is only available on Samsung devices. But within this year, SAPA is running on the Android audio system. Because thanks to the Android Pro Audio, the low latency is available on Android audio system. That means SAPA is also available on non-Samsung devices. So, thank you. So Samsung decided for the next flagship device, our next flagship device, we're going to support the Android Pro Audio hardware flag. Thank you. And if you need more information, please refer to the URL here and send the questions to sapa@samsung.com. And if you have any urgent question, ask me or Johnny.
Thank you so much for coming today. We look forward to seeing you at the demo booth, too. Thank you.